In this video, we're going to be talking about the shape of a distribution and how the mean and median compare when you are looking at a data set that maybe might not be beautiful and symmetric. So the mean and the median are both measures of center, but if we have what's called a skewed distribution, the mean may not actually be what a typical person in the data set would be, or a good describer of center. So each one of these histograms here have a class width of 1. We would call this symmetric or symmetrical. In that case, the mean and the median are going to be pretty much the same. However, if you have a histogram with a tail that pulls to the left-hand side, this number here, 4, with the mode over here at 7, the mean is going to get pulled towards that tail side, and the mean's going to be less than the median. That 4, the value of 4, is going to take the value of the mean and make it a little bit smaller than the halfway data set point. Similarly with skewed right, just the opposite direction, this 10 right here is going to pull the mean to be a little bit larger than the median because the value of 10 is larger and the mean depends on the actual data values themselves. Let's look at a couple of these graphs, talk about the shape, and then talk about the median, mode, and what we think the mean would be in relationship to the median. So this first one is the 2010 Winter Games gold medal wins by the top 20 medal-winning countries. Notice, because I have this peak here at 1 and this tail down here, I would say that this is skewed right. Since there are 20 countries, I keep saying countries, we would want 10 to be in each of the halves. So we already said this is the mode. And then the median, let's count, is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is where the data gets cut in half. 10 data points are over here. 10 data points are over here. That means our median is going to be 3.5. It will be the data point between 3 and 4 right here. Since we have this skewed right distribution, this country with 14 gold medals means that the mean is probably going to be greater than the median because the mean is going to depend on the actual data values themselves. So that 14 or even the 10 and the 9 are going to take the mean and make it much larger than 3.5. All right, let's look at part B. This is the stem and leaf plot of the ages in which former US presidents have died. It is not perfectly symmetric, but notice the mode peak is in the 60s. Okay, and so we don't have to think about the mode being the actual number value. Now we could look at it. It would be 57 and 67. It looks like both of those are triples for the actual mode, but you're really looking at the peak when you're looking at finding the shape. So because the mode peak is here in this middle, we would say that this is symmetric. All right, let's find the median. It does not give us the total here, so we need to count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 2, 3, 4, 5, 6, 7, and 8. So 30. I feel like I counted that wrong. Oh, darn. Let me try one more time here. Okay, I recounted and it's actually 39. Okay, so since we have an odd number, that means that an actual data point is going to be our median. 38 divided by 2 is 19 in each half. So let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And so that 20th data point is going to be our median, and then there should be 19 over here. All right, and that's going to be approximately the same as the mean because we have that symmetry, approximately symmetric distribution here. All right, our last example in this set is skewed to the left. The mode, we do not have the actual numbers here, so I'm just going to say that this is my peak. So my mode is somewhere between 20 and 25. And what's going to be a little bit tricky here is also finding the median because I don't have the actual data values. All right, so it looks like this is a random sample of 2 plus 3 plus 4 plus 7 plus 9, 25 students maybe. So again, we have an odd number. I'm going to have 12 and 12 in each half, and then that 13th data point is going to be where my median is. Well, 2 and 3 is 5, plus 4 is 9, plus 7 is 16. So my median is going to be in this bar right here. I don't really know what that is. I might just approximate it halfway. So I might say like the median is then going to be approximately, let's see, halfway between 15 and 20. So 17.5. And then since it's skewed left, I know the mean is less than the median. Let's take a little deeper dive into the difference between mean and median when it comes to an example like number 2. So let's say there's 50 people in the town. One person is a millionaire, the other earned $30,000 a year. So if you think about this on a number line, right, you have all 49 people down here and then one all the way over here. What is a better measure of center? Well, your median is going to be in that 30,000. But this one person that does make $5 million is going to pull the mean that way. So if you want to say the typical person in this town and what they make, you probably should report the median because the mean is going to get skewed to the right because of that one person earning $5 million. If you wanted to actually calculate that, you could do 5 million times 1 and then 30,000 times 49 and then divide that by 50. We could do a weighted mean to find the actual mean, but the concept itself is more what I want us to get at is that because the mean depends on the actual data values, that one person will pull the mean or skew it to the right.